let's might as well get into it. So last week we weren't able to finish the part about blocking and non-blocking code. So I moved that over to this week, and we'll take a look at that today, obviously. The full agenda for today is a little ambitious and probably not going to be what we're going to cover entirely. We're going to look at blocking and non-blocking code and how to deal with non-blocking code, because obviously because it's asynchronous, we have to be able to manage that in some way so that we can actually have things happen when we want them to. So we're going to look at promises a little bit and callbacks, obviously, but you guys should already be semi-used to callbacks by this point, but it doesn't matter. We'll cover them again. It does say on the note that we're going to take a look at async and await, but I've actually postponed that. I've had a few students that are absent this week, and they really want to learn that concept, so I'm going to postpone it to the following week. And then what else? Understanding middleware sounds complex. Really isn't. You guys have already actually been using middleware. Just out of curiosity, how many of you took Model View Controller Systems, MVC, either in PHP or in ASP? Okay, so you guys have already used routers, probably, so you should have a basic understanding of routing. If not, not a big deal, because we're going to cover it anyways. And actually, you'll probably get a more in-depth view of how routing actually works in this class, because it's more granular. So it's kind of cool. So you'll kind of have a better understanding of what happens with routing. We're going to create a very, very simple node server. We're not even going to deliver any HTML or anything like that. Just a very basic node server, and we'll just spit some text in the browser, and that's it. And then it's written that we're going to deploy to Heroku, but I've extended that to next week. We will do the deploy to Heroku when we get back in the beginning of the class. And then you'll be able to work on that lab as well, because that lab will actually cover those same steps, creating a node server and deploying to Heroku. So that lab I've already extended. Some of you have already reached out because the stupid thing sent out notifications and stuff, and you guys freaked out and sent me emails saying, this thing's due, how do I complete it? That's actually not due till the 30th, so it's like 2 weeks away. Right? And I'm not going to assign it till next week. So if you already have a good understanding of Node or whatever and you want to jump ahead, feel free. The notes are there. You can pretty much just go through the notes and immediately do the lab. So if you want to get a jump ahead on it, that's totally up to you. Labs can be done in groups, which reminds me, I did put up in the resources. Now, you don't have to work in a group. That's completely up to you. But under the group member sign up, you will see this wonderful Google Doc. This is specifically for your class. It's already got group 1, group 2, group 3, whatever. You can change those group names. If you want to come up with a group name, you can. Add your members, and the project ID is not necessary. The whole reason why I need this is so I can add your groups into Blackboard, right? So that way, if you have a group, you're all degraded for that group, right? So I can mark it one entity. If you don't want to work in a group, that's entirely up to you. None of the projects or assignments will be grand enough that not a single person can do it. So you can do them individually. Even if you're going to do them individually, though, please put your name on this sheet, right, under a group slot so that I can see you're working on your own. So like group 5, for example, could be Tran, right? So he's got his name under here, not a problem, okay? I know that there's no other people in this group, but that's totally fine. Just make sure you're added in there, because I have to create everybody in a group in order to grade it that way, even if there's only one member of the group. Yeah, just the way it works. All right. Yes. Make sure I know all the members of your group. Inside joke. Anyways, I guess we might as well get started. Is there any questions about that particular part? So the things that are actually group-based are labs and the project. They're the only things that are group-based, except for the tests. Sorry, the tests have a group component in them. But again, let me be very clear. It's not a requirement for you to be in a group. Obviously, if you're in a group, the marking increases a little bit, right? I need to scrutinize you a little bit more. If you're doing an individual, I'm a little more lenient on it. But just keep that in mind. I do recommend working in a group because you will work with teams, obviously, when you're not, when you're out of school and you're working in the industry, you'll obviously be in teams anyways. So you should get kind of used to that idea and working with other people, especially working with tools like Git and stuff, right? Which are community-based tools, and they help you to be able to collaborate properly. So those type of things you should really be focusing on. Okay, let's get into it. Let's talk about blocking versus non-blocking code. So you can find these notes if you want to follow along. They're under weekly learning. Under the weekly learning tab, you'll notice there's 2 weeks there. We're on week 2. Asynchronicity, which is a fancy term for non-blocking, right? So blocking would be synchronous, synchronicity, right? Asynchronicity is non-blocking. And you underneath there, you will see our lesson. That's the lesson plan. There's the Heroku link, but don't worry about that right now. And then there's a quiz, but you will have time in class to complete the quiz, so don't worry about that either.
And the quiz is based on lesson 1?
It's based a little bit on lesson 1, yeah. The questions are not that bad. However, you don't have to do the quiz in class right now if you don't want to. You can do it at home. It doesn't close out until tomorrow at midnight, and you have 2 attempts. And there's only 5 questions. Okay? So like the basic idea of the quizzes is for me to be able to gauge how you're progressing and where your knowledge is. So cheating on them is completely pointless because there'll be more than enough bonus points in this class to make up the quizzes, so don't worry about that. Don't cheat on them. Don't work with your friend. Try to do it yourself because it gives me a better understanding of where you're at, right? Which means you guys can be more successful because I can slow the course down if it needs to be. All right? So let's just keep that in mind. Cool. So if you go ahead and open up that, you can actually see the notes there. I'm just going to talk a little bit about the blocking and non-blocking element, and then we'll write some code.
Doesn't work.
What's that? Why are you getting a weird XML error? That's bizarre. Try right-clicking on it and opening the link in a new tab. Does it open for you?
Like this?
Yeah. If not, you can always... Wow, it's just dangerous. Yeah. Continue to the site.
I did. That XML.
That's so super bizarre. Is anybody else getting like weird errors?
No.
Do you have what browser are you using there? Oh, Chrome. Okay.
Do I have to like S6?
Just download it. Download the file.
Okay.
Then open it up in like a PDF reader of some sort, because it's just a PDF file. Yeah, that's super weird that it's doing that to you. All right, let's talk a little bit about blocking and non-blocking code. So blocking and non-blocking, to put quite frankly, is basically synchronous versus asynchronous, right? So when we think of code, the code that we've written up to this point, the code that you guys wrote in Java or in PHP or whatever languages you've been working in, they've been procedural, and they usually, well, they probably have been, blocking, right? Has anybody done threading at this point? Does anybody... A little bit of threading? Yeah. So unless you've done threading, then everything you've been writing up to this point has been blocking. So the idea of blocking code is that I execute line 1, then I move to line 2 and execute line 2. Even if I have a function name in there and I'm referencing out a function, all that happens is my cursor now moves to wherever the function is, starts executing those lines, and then we'll return back where it was. Asynchronicity, the idea behind it is that I will execute line 1, right? And then if there's a delay, or I need to wait for something else to occur, I will move in the stack to somewhere else and start executing the next piece. And I can keep jumping around my code. I don't have to move in a nice, procedural fashion. I don't have to go step by step. There's no sequence. I don't have to be sequential. I can actually execute things relatively at the same time. The thing is, the big thing about asynchronous code to remember is it's not the same as threading. It's not identical. Threading actually allows things to happen simultaneously. So if I have 2 functions called greeting, for example, with threading, I can execute both those functions to the nanosecond at exactly the same time. And both those functions will output at the same time because they're in their own threads. So they'll process at exactly the same time. With asynchronicity, it's a little different. I execute, say, greeting here, right, and execute, say, greeting here, but they'll start slightly out of sync with each other, right? And what will happen is this will execute, and if it's waiting, this one will start its process. The next time this one actually starts to communicate again, it will finish off its process, and then this one can finish off its process. The big cool thing about asynchronicity, though, is this doesn't have to be complete before this one starts. I find a lot of people when they start with JavaScript, they're like, oh my god, this is going to be absolute torture. How am I going to understand this or remember this? The good news about JavaScript and asynchronicity is it only actually affects a few things in JavaScript, about 10% of the actual commands that you will use in JavaScript run asynchronously. Majority of the commands you will work with are synchronous, which means they're procedural, they're blocking, right? But there is that small little 10%, and that 10% is something you're going to need to know, especially when we're running things like servers, and we're handling requests from people, and we're dealing with event-based type information. So let's talk about the actual asynchronous things that you're going to find. So asynchronous operations in JavaScript, they tend to be, here I'll zoom in a little bit so you can see here, Trent. There we go. So the asynchronous operations, they tend to be HTTP requests, okay? So our user has made a request in, or we've made a request out to the internet somewhere. Because we don't know how long that request is going to take to actually give us back a response, we can instead move on to other pieces of code and start executing those other pieces of code. And then when it's done, we can deal with it at that point, okay? Other languages, they stop, right? Like that guy said in the video, it stops the world, right? They would stop the world and wait for the response. So you can imagine how bad that would be if a timeout's like 30 seconds. You're now waiting 30 seconds for that response to come back, and you can't execute any further code. JavaScript doesn't do that. JavaScript instead, because of its asynchronous nature, allows it to move on to the other code, and then once that response comes in, you can handle it at that point. So in addition to HTTP requests, we also have file requests. So file requests is you reaching out to the file system and requesting a file, or you transmitting a file to the file system. You can do that asynchronous, which is great because based on the size of the file, you don't necessarily want to be waiting on reading the whole file. You want to be able to execute other code, and then when it's finished reading, you can then deal with it and start working with it. Same with writing operations. Writing operations are also asynchronous. Set interval and set timeout. We'll take a look at these two cool functions today, but basically you can think of them like for loops or while loops or something like that, but asynchronous. They operate asynchronously. So they will loop in the background continuously, and on each iteration they will execute their code, but the rest of the code in your document will continue to run. We're going to actually take a look at a very simple example of that, which will be a lot more beneficial than me trying to explain it. And then any event registered functions. So you might remember from last semester, we took a look at binding functions to like click events or hovers or focus or blur, those type of things. Well, all of those are still asynchronous. The listeners for those are asynchronous. They will sit there and listen, and the rest of your application will continue to run. Then once one of those events executes, then it will actually cause the register function to do its process, whatever it needs to do, okay? Now it seems like it's a complex topic, but it's actually fairly simple, and we've got a nice example that we're gonna go through. So if you wanna go ahead and open up your IDEs, whether they're Sublime or VS Code or WebStorm or whatever it is that you're using as an IDE, just make sure that it actually handles JavaScript. And then while you're opening that up, also make sure you open up either your command prompt, PowerShell, or terminal. One of the three ways that you're using to be able to access, a shell environment. Now, something I don't think I taught last week, we can actually use our file system, go and create a folder, and then drag the folder into the PowerShell to get there quickly, which is kind of convenient. So if you open up not Internet Explorer, but if you open up File Explorer or Finder if you're on Mac, right? If you're on Linux, it's the little folder thingy. Once you're in there, go ahead and navigate to wherever you want to put a directory that we're just going to basically do today's examples in, okay? Feel free to put that wherever you like. I'm going to stick it in this 2068 directory, but I'm going to create a new folder, and I'm going to call it Thursday. And then I'm just going to position that folder just slightly beside my terminal so I can easily drag it over to my terminal. But before I drag it into the terminal, I want to just start the terminal with CD and a space. CD, which will allow us to actually get into the directory we need to get into, right? Then I'm just going to click, drag my folder in and drop it. And it will actually complete the whole path for me and drop it in place. Okay? Don't type that path because that doesn't exist for you. You need your own path. Right? So make sure you drag in your own folder. Once I'm done, I hit enter, and now I'm in that directory. The reason why I want to be in this directory is because the code that I put in this directory, I want to execute it, right? What is the command that we use to execute code? Just node. Yeah, you were so close. Node and the file name. Yeah, that's the key pieces you need. You need node and the file name. So once you're done that, you can go ahead and go over to your IDE, go to File and open that same directory into your IDE. Okay. And obviously it's empty. We have no files in there yet, which is totally fine. I think what we'll do is we'll do the same thing I did on Monday. We'll create a file for each kind of thing that we're learning, and then you'll have a nice little batch of files with our examples in it. Okay? I'll also post our final example when we're done online as a zip into our week directory, so you have a copy of it as well. I know some people like to just watch. They don't want to actually follow along, and that's totally fine. I'm totally okay with that. All right, so the first thing we want to actually take a look at is blocking and non-blocking. So I'm just going to create a new file in here, new file, and I'm going to call it block.js. And just ignore my ES Lint thing that comes up. I need to fix some of that stuff still. And I'll make this a little bigger so you can see it. Whoa. Everybody's got a file. I'm just going to close my sidebar. Because I have to zoom in, it makes the sidebar ridiculously big as well, which obviously, I lose a bunch of real estate. So I'm going to close it. I use Command KB to close. Might be Control KB on your systems to close your sidebar. If you want to, or you can leave it open. It's totally up to you. All right, let's first take a look at blocking code. We've written so much blocking code, it's not even funny, but we'll do one just so we can demonstrate it. First, I'm going to actually just create a function. So here's my function. I'm going to call my function say hi. And it's going to have one parameter called name and a block. Okay. For those of you that aren't aware, that is what a function syntax looks like in JavaScript. Still operates the same as a function in any language does, though. The idea of a function is to encapsulate reusable code, right? Same idea in JavaScript, doesn't change. Just some of the syntax changes a little bit. Looks closer to what you would write in PHP. And then I'm going to just write a console log. Console log actually outputs to our stream buffer. Every language supports that same operation. In PHP, you use echo. In Ruby, you use puts. In C++, you use print, right? I think in Java, you use print. Yeah. In JavaScript, you use console log. And then we're going to use some backticks because we're going to do string interpolation. We're going to start getting into the habit of using backticks as our quote character. You can find the backtick key under your escape key. It's the button directly under there, and it looks like that. So it's basically a set of quotes, but they're on a slight angle, right? The cool thing about backticks is they give us something called string interpolation, which basically means that we can write JavaScript expressions in there, and they will be evaluated. So it's not just a string. It's a string and then some, right? The key point to know, though, is that those interpolated strings, that expression gets evaluated and dumped into the string in that order of operations, then the whole string goes back to whatever the function is, right? So the expression gets evaluated first. That's the order of operations. All right. I think I make it sound more complicated than it is. We're going to say hello, and then I want to spit out that variable. So I'm going to use the expression evaluation syntax, which is $, and a set of curly braces. And then in there, I just write name. And that is function done.
Which IDE are you using?
I'm using VS Code. You can use Sublime or WebStorm. There's a whole bunch of them. Or if you're more comfortable with something like Dreamweaver or Eclipse, you're welcome to use those as well. They all support JavaScript.
I just happen to have a few. I have Atom, I have JavaScript.
Atom's good. Atom's really good. I know Scott McCrindle is a big supporter of Atom, and Atom actually has kind of similar similar structures that Sublime and VS Code have. All right, so the next block, the next piece that we're going to do is blocking code. Blocking code is pretty standard. You guys are used to this. The idea of blocking code is that it happens in a sequence, right? So I execute line 1, then I execute line 2, then I execute line 3, right? I'm not going to execute line 2 before I execute line 1. Doesn't work like that, right? So we're going to use our function. We're going to execute it by calling it, say hi, right? With a set of parentheses, right? The parentheses is where we're going to put our argument, right? So the first piece that we put in here is called a parameter. This that we put in here is called an argument when we go to pass it. And I'm just going to put in a name. So I'll just stick with what I did on Monday. I'll put Cabal in there. I did. You don't have to. You can use single quotes, double quotes, totally up to you. I just forcing myself to get into the habit of using the backticks because it's actually the preferred quote character. Plus, then you don't wind up with things like needing to escape apostrophes, right? Or weird things like that. So, yeah. I'm going to do another one. Say hi. Some backticks. And I'm going to do Devin. And then, just because I feel like being super lazy, I'm going to duplicate this line down and then just change out the name. The way I do that on my computer and my IDE is Command-Shift-D. It might be Control-Shift-D for you. If you're on Mac, it's Command-Shift-D for sure. And then I'm just going to replace the name. And I'll just use Connor because I work with him all damn day. So. Actually, a quick little side note, just before I do this, how many of you actually know Connor? Connor Mindley? Okay. So Connor's working in a system right now called Site Condor for us. And the Site Condor, basically what it does is it assesses a website. So people send it out to go crawl their website, come back and bring back their information about their site. You know, how many H1s do you have? Are you using them correctly? Do you have metadata? Stuff like that. Important details about your site. So we have a client who owns an e-commerce site, and they sent it to crawl. Well, their e-commerce site has over 20,000 internal links. So it crawled 20,000 internal links and built out the structure for it and blew our memory out because we didn't have enough memory to actually store the entire string of data in memory because it exceeded 1.9 gigs. That's a lot of characters, right, in order to exceed 1.9. So Connor has had to learn how to actually put things into a stream and then try to stringify a string, which is super complex. But that's the stuff you learn when you go out and work in the industry because you don't learn that really here because we don't work with strings that are 1.9 gigs in size. And that's a note, the actual language that we're working in right now. Anyways, side note. I'm going to add a comment above this. Blocking code example, just so we don't forget what this is. And I'm going to save that. And I'm going to attempt to open my terminal up at the side and hopefully not block all this. We'll see how it goes. It should open up. I'm just going to move it over to the side. Yeah, it's not so bad. I'll zoom in a little bit so you can see what I'm doing. Cool. And then what I'm going to do to execute this file is I'm going to type in node space and the name of the file. So the name of my file is block.js. So I'm going to type in node space block, and I'm super lazy, so I'm going to type in BLO and hit tab and let it autofill. Yes, Bo?
What's the difference between the terminal and the Visual Studio Code and the actual terminal? Because I ran my code.
In VS Code, the terminal that you open up is identical to your preferred terminal on your system.
Can I just use that?
Yeah, you're totally welcome to use that.
It's so easy.
Like when I open up mine, it actually opens up my little iTerm with ZSH and all my fancy little doodads that I've got in it and stuff. Yeah.
When you dragged your file over to open it up there into that directory, did you do anything other than
I
drag
did.
it?
I typed CD space, then dragged it over and dropped it and hit enter. So if you've got the file path in there and you need to add CD, you'll just have to use your cursor key to go to the beginning of the line. So type CD. Yeah. All right, I'm ready to hit enter. You guys are probably ready to hit enter. Hit enter, and you will notice that the order that it spits these out in is the exact same order that we put them in. Now, all of these have 5 letters in it, right? So you could argue and say, well, they all have 5 letters, so obviously they would happen in order, right? They're using the same amount of memory. If you want to prove against that, you know, all it takes is a little bit of gobbledygook. This gobbledygook is a little shorter. This gobbledygook is a little shorter, right? So based on that theory, the last one would execute first, and we would go in that order, right? Because it consumes less memory. If I execute, nope, they still happen in the nice procedural order. Nothing breaks. And that is because this function is blocking, and these operations are blocking operations. We have not done anything asynchronous. That's really triggering my OCD, so I'm going to put those back. Let's take a look at an example of non-blocking code. And I'll just add asynchronous in here as well. There we go. Like I said before, set timeout and set interval are both asynchronous operations. They will not prohibit other events from occurring. They will just live in their own little environment and do their own little thing, right? So to prove that, we can actually use the command set interval. So it's set interval with a capital I, and that's a function that's built into the JavaScript API. And set interval takes 3 arguments. One of them is optional. Sorry, 2 of them are actually optional. The first argument is the function we want to execute. So remember those wonderful callbacks? Well, it wants a callback function. The second argument it wants is the time. How long do you want to wait before you execute this function? So it's a delay. Set interval is a little bizarre, and it kind of trips them up. What this basically says is after 500 milliseconds or whatever time you give it, execute the function. So it's not going to execute the function, then wait 500 milliseconds, then execute the function. The first time it runs, it will wait 500 milliseconds. There will be a delay before it executes, which I think you encountered, right?
Yes, but I want to avoid that. I didn't like that.
The only way to avoid that
Yeah.
is to, above it, execute the function. Execute the function, then run set interval and let it execute after 500 milliseconds. Makes sense, right? Okay. So we're not going to write a callback. We already have a function. We're just going to give it the function that we want. Remember, in JavaScript, functions are purely just definitions, right? That's all they are. But we use an operator, these parentheses, to execute them, which means we can pass functions around our application just as a value without the fear of executing it. Right now, we want to actually do that same thing. We just want to pass it as a definition. We do not want to execute it. Otherwise, it will attempt to execute the return value. So we're going to write say hi without the parentheses. Press comma. The second argument is the amount of time that we want to delay for, right? So I'm going to delay for 2,500 seconds, or 2,500 milliseconds. Sorry, I wouldn't make you wait that long. And then the last argument is optional, but it's really important. What it is it's a list of arguments that you want to pass to the function. So say hi takes one argument, right? So we have to just give it the list of arguments that we want here, and it's just literally comma separated. So we're just going to give a name there. Nice and simple. And there we go. Now I want to do another one as well, but I'm going to give it like 5 seconds to execute. So I'm just going to duplicate that line with Command-Shift-D. It might be Control-Shift-D for you. Or you can just copy and paste. Or you can type it out from character to character. Totally up to you.
Shift-D.
Command-Shift-D for me, Control-Shift-D probably for you.
Not
No,
VS
it's
Code,
not
it is
one.
in VS Code that opens debug, but
Okay, so
Shift Alt down arrow copies a line below it.
that's annoying. Shift-Alt-Down arrow in VS Code. That is really weird, yeah. I also use the Sublime
Thank you.
shortcuts.
I kept pressing Command D and
Yeah.
we have like Sean, what are you talking about?
I have Sublime shortcuts in VS Code,
Oh, okay.
so I just keep using the same ones I've always used. So yeah, sorry. My apologies. This one is Goggin Deep because I use examples of people I know. That's it. I have a very tiny little world. All right. So I am executing these two functions, right? And basically what's going to happen is after 2,500 seconds, or 2,500 milliseconds, 2.5 seconds, it's going to spit Michael out. And it's going to do that every 2.5 milliseconds. It's going to do that forever. It's never going to stop. Say interval, same thing. It's going to do that every 2.5 milliseconds. But I wanted to change that to 5,000 so that it's 5 seconds. There we go. Now think about this. If this was procedural code, you couldn't do this, right? This would execute forever and never stop. And everything below it would be null and void until we finally got this guy to stop, right? Just like any normal loop. You have to exit the loop in order to operate the next loop. But because these are asynchronous, what you're going to see is it will spit Michael out, then it will spit Michael and Goggin Deep, then it will spit Michael out, and then it will spit Michael and Goggin Deep. And it will keep doing that over and over and over again. So let's go ahead and open up our terminals. I'm going to clear it out so you can see. Press up. And then after 2.5 seconds, there we go. 5 seconds, 2.5 seconds, 5 seconds. Just keeps doing it. So they're not blocking each other, right? They're happening asynchronously. When it comes up to time, the event buffer says, oh, cool, I have something to spit out to the console. And there it goes. Right? Yeah, so that's the thing. How do we stop this thing that's now an infinite loop? Do you know how?
I know. I figured out this morning because last night was horrible. I have a classes. I
Right.
subscribed to a function, and that function inside the function has an interval. So I click this loop.
And just
Click
go over it?
that, 2 loops.
Oh,
And then-
geez, yes. I see
Yeah,
what
it
you're
was
doing.
horrible. But this morning I figured out clear interval.
Yep, clear interval is a command that you would use inside the thing. But what do we do when we're in our terminal and this is just happening forever? How do we kill it?
Control C.
Control C, exactly. Control C will kill it, and that's universal. Doesn't matter what operating system you're in, Control C will kill that. It actually tells the process to stop running. So we're not quite done yet. That's fine, but I really want to show how this is asynchronous, right? I am going to put 2 more say hi's under here, just the typical blocking code. I'm just going to put them right underneath here. And what you're going to see occur is it's going to say hi, say hi, say hi, say hi, say hi, then run this, then run. Okay? And you're giving me that doubtful face, but I will show you. So say hi, Mo, and say hi, Nur. Only because of your faces.
What is this?
So now when I execute, we're going to see 5 names get spit out to the screen. Then after 2.5 seconds, we'll see say hi Michael. Then we'll see after 5 seconds, say hi Michael, say hi Gaganti. Due to the wonderfulness of asynchronicity. There we go. All 5 names spit out to the screen all at once. And that's because these are not blocking. These register and say these things are going to happen at 2.5 seconds and at 5 seconds. That's all it does. And then it lets the code continue to exit. It doesn't stall here and wait. It doesn't stall here and wait. It continues to execute the code. Now that is a very simple, extremely simple asynchronous example, right? We're going to be using asynchronicity a lot. And the nice thing about it is you're not even really going to notice. You're just going to use it, and that's just the way it's going to work. And it's not really going to be something that you're going to pay that much attention to. But hopefully this will help you understand better why it's happening and what's happening behind the scenes. Are you all right over there? No? It's just death from here on forward. Now I mentioned callbacks, right? So say hi is a callback function. We pass this in. In the simplest explanation I can give for a callback, it's a function calling a function. That's what a callback is. It's a function that you provide to another function to be executed. That's it. The cool thing about callbacks is that you can now choose within your function where you actually want to execute it. So why don't we create a new file? So open up your little file explorer thingy, right, in your projects and create a new file. Call this one callback.js and hit enter. So now you should have 2 files, one called block.js and one called callback.js, or whatever you want to call it, doesn't really matter. As long as you know how to access it. Okay, I'm going to close my sidebar. So callbacks are essential to asynchronous programming. They're not exclusive to it, though. You can actually have callbacks in other programming languages. PHP supports callbacks, interestingly enough, which can come in really handy, especially if you're trying to do metacode. I believe, well, I know C++ supports callbacks because of pointer memory, and you can actually just reference that pointer. And I believe, I would be very doubtful if Java didn't support callbacks. I'm positive Java supports callbacks. It's got to. So most languages do support callbacks. Ruby definitely does. So callbacks are really handy. However, in asynchronous programming, they become absolutely imperative. The idea of a callback is that once I'm done, you know how I said when we do an HTTP request, we have no idea when that request is going to come back. But we want to do something once it does. We want to execute some code once that response is back. That's where the callback comes into play. The callback allows us to execute a function once we get a returned response. And we can pass that response into the callback and now have access to whatever data that is. Okay? So let's take a look. So callbacks are essential to asynchronous programming, not exclusive to it. Simply put, a callback is a function that is passed as an argument to another function to be called at a later time. Callbacks are probably one of the most confusing programming paradigms for beginning programmers, but really they're not too bad. They're pretty easy to use. Once you get a wrap around it, you can really realize how powerful they are. So let's look at an extremely basic example of callbacks. So we're going to create a function. Our function that takes a callback. And I'm going to call this function farewell. Kind of the opposite to usually what we create. Don't worry, we will be creating a greeting one. Farewell. It has one parameter called name. And it's just going to console log. Some nice dirty backticks. Goodbye. $, name. We haven't yet created a callback yet. We have a function that just takes a name. This is just a basic function, like any other function we've created before. So now I'm going to create a function that actually takes two parameters. It's going to take a name, and it's also going to take a callback. Okay? The cool thing about this is that it doesn't change our syntax. Name, callback. As far as JavaScript knows currently, name and callback are meaningless. They are just placeholders for values. It has no idea what those values are going to be yet. We haven't distinguished what they're going to be. JavaScript, as I've stated tons of times before, is a duck type language, right? Walks like a duck, quacks like a duck, must be a duck. That's the way JavaScript is. If I pass name as a string, then because it looks like a string, smells like a string, tastes like a string, must be a string. If I pass a function to callback, again, the same rules apply. Looks like a function, smells like a function, must be a function. Okay? So I'm going to do console.log, hello, and then interpolate name. And then once it's done that, I'm going to call my callback. Now, as I've said before, this function that's here right now, this is what the definition looks like. In memory, it's really just from this point to this point. That's what's being put into memory currently. This farewell here is just a symbol. It's a symbol that points to that point in memory so that you can easily understand what it is that this belongs to. The cool thing about this is I only need to give this symbol as the value to my greeting, as the callback. I don't want to execute it, right? And in order to avoid executing it, I just simply don't give it the parentheses. So to call this in the function, I'm not going to call farewell here. I'm going to call callback and execute it with the parentheses. And then when I go to execute greeting, I will pass farewell as the function. So why don't we write a comment above this? Simple function takes callback as argument. And the top one actually should be our function that we'll use as a callback value. There we go. That makes more sense. Now I want to call greeting. I want to pass it my name, and then I'm going to pass it the callback. Okay? So to do that, call greeting, pass name, and farewell as callback. Cool? So greeting with brackets, my name, Sean McKinnon, and my callback, which is just farewell. It's very important you don't put the parentheses on it though, right? We're just passing in the definition. This thing will add the parentheses to it. So the way this is flowing is this farewell is going into here and replacing this value, right? And then when we execute it here by adding parentheses to it. This is farewell. The real power to this whole system is that if we ever want to change out farewell, right, get rid of it, do something a lot more complex, we can and pass a totally different argument here, right? A totally different function. Or maybe we dynamically want to call a different function based on who their name is, or maybe their age, or some other details, and we dynamically want to call something else, right? We can do that because this is simply a parameter. And whatever function definition we pass in there, we're going to call. We're not biased in any way, right? So let's go ahead and save that. Open up your terminals. Whoops. Open up your, here, I'll fix that so you can see. Open up your terminals. Type in node, callback, hit enter. And we have hello Sean McKinnon and goodbye undefined. Well, the reason why I have goodbye undefined, does anybody know why I have goodbye undefined? Exactly. We didn't pass the name. Farewell has a parameter called name. And we didn't pass that in the callback call. So let's just make sure we call that. So we'll pass name in there, and then that should fix that. That wasn't planned, despite how perfectly I handled that. Gonna open up this, and now it says, hello, Sean McKinnon. Goodbye, Sean McKinnon. And notice the order it happens in, right? So I'm in my greeting function, I execute this logic, then I'm executing my farewell logic after that. And like I said, I'm not limited to using farewell. I can create whatever function I want and pass it to it, and it will execute that function. Yeah.
Can you explain again how like the callback is the farewell?
Sure. So this is our function called greeting, right? Has two parameters, callback is one of those parameters, right? I can pass any function definition there that I want. Doesn't matter what it is.
Also, the second parameter is always like passing a function.
Doesn't have to be. JavaScript doesn't know that. JavaScript's not going to know that until it tries to do this.
Okay.
Yeah. The second it attempts to do this, if I passed a string here, it's going to blow up and say, no, dude, that's not a string. Right? You told me that this is a function because that's what you're trying to do with it. Right?
Right.
So, yes, we're going to pass a function in here. We can pass whatever function definition we want, though. We don't have to pass farewell. We can pass literally anything we want. When we do, it will execute it. That's what will happen.
Okay.
Does that make sense?
Yeah, a little bit.
Yeah. We could actually, can we, trying to think if there's any functions that are just easy to execute that I don't have to write a whole new function for. There isn't. Why don't we write a different function? Just underneath farewell. Actually, let's do it after greeting, just so we can kind of keep our things all together. I'll do it after we did this call here. Function, say hi, Mo. There we go. Say my hi, Mo will actually take no parameters, but that doesn't matter. That's totally fine. And I'm just going to console log out. Hi, Mo. So in the above one, I passed farewell. I'm going to do this exact same logic, right? I actually don't even need to pass a name. Well, no, I do need to pass a name. And then I'm just going to pass say hi, Mo as my argument for the function. So, greeting. Burakacha, my favorite go-to phrase. Say hi, Mo. Save. So I'm passing in say hi, Mo to greeting. All right, so let's go ahead and execute that. I get hello, Sean McKinnon, goodbye, Sean McKinnon, in the first one, right, because it executes farewell. Right. I get hello, Burakacha, and then I get hi, Mo, the second function. See how powerful those are?
Yeah.
Because now you can just literally hand it whatever function you want, which makes it really super powerful, which means you can do dynamic-based function operations. This also gets closer to something called factory design pattern, if you know what factory design pattern is. It's also fundamental for things like dependency injections stuff like that, which are a little bit more sophisticated coding. But this is the fundamental operation, being able to hand code to a function. Go execute this thing, right? Cool. Any other questions about callbacks? Yeah.
So are functions not stored as keywords on execution?
Are they not stored as keywords?
Yes.
Um,
Function declaration, it's not stored in
It will be stored in. It won't be stored in heap. It would be stored in. Crap. Wherever they store data literals is where it winds up going, which is in heap or stack. There's like a whole different allocation for that.
But then each function afterwards we have to ask for these functions.
No, you can definitely use the keyword of the original. Like if you wanted to just hard code farewell in there, you totally could. You don't have to pass it as a callback if you don't want to. But it's the power of callbacks that you would do that, right? But what it's going to do, just because you're interested in the memory side of it, it's actually going to take farewell as the symbol name, go look up the memory location of it, find that definition, and paste it into the location when it does its compilation. Yeah. All right, cool. Nice. Let's take a look at callbacks for asynchronous operations. So how do we want to title this? Oh, yeah, this is this one. If you are easily offended, I recommend just watching this. Don't type out this code. If you're not, and you kind of want to see how it works out and plays out, then type out the code, okay? That's my precursor here. So I'm going to create a new file, and we're going to call this async. So async dash callback.js. I mean, could you get away with anything in this? Yeah, if you don't want to use the address I give, you could literally use any address you want. It doesn't matter. Any URL will totally work as long as it's an HTTPS address. But we're going to use the fun one. All right, I'm going to collapse that. First thing we're going to need, don't get hung up on this, we're going to need a library available to us that's built into the core of Node. It's called HTTPS. We're just going to assign it off to a variable. We will look at this type of stuff more in depth later on this afternoon. That's require. Go away, you stupid light bulb. I'd say that's the only downfall to this theme. I don't like the light bulb. That's in the way.
Well, you know, if you go to the extension, you actually download the theme
That is the theme.
like, from the actual.
Yeah, because Visual Studio Code, its light bulb is just a regular light bulb. But the synthwave theme flips it out to a fluorescent bulb. But I think the CSS is causing it to go in a weird location. All right, so the first thing we're going to do is create a function. And do I want to do this simply? Just because of the number of people in here that are still kind of unfamiliar with JavaScript, I'm going to write this as a simple, normal function. I was going to do it as an anonymous function, but I don't think we'll do that. So we'll do function get insult. We're going to set a parameter called callback. And there we go. There's the structure of our get insult call. And I think after this I've set for the break. Yeah, after this we'll take a break. All right, so we have that. So first we're going to need the URL, and this is the thing you'll replace if you don't want the insult. You just need to use https://example.com. That works totally fine. The rest of you, it looks like this. So it's const URL equals some backticks https://insult.matbass with 2 T's and 1 S .org/API/insult. And because of my text wrapping, it went to the next line. That is not entered onto the next line. It's just wrapping. I did. That is not how we spell insult. That is inulst. There we go, insult. Actually, I think even the second insult you don't even need. I think it actually just API is totally fine, but I could be wrong. Pretty sure I tried it. All that is a string assigned to a variable. That's it. No magic there yet, right? All we've done is assign a string to a variable. To a constant variable, right? Next, we're going to use the HTTPS library to actually make a request to the API and grab an API result. So we're going to do HTTPS.get. So HTTPS is an object and get is a method on that object. You want to be super technical in JavaScript, there are no methods, there's only properties, and that just happens to be a property with a function definition. All right, so get. First, we're going to give it the URL. That's its first argument. And then its second argument is the callback. And the reason why there's a callback is because this request sends out to this URL, and then it waits for a client response. So it returns back a client that you can now pull, right? But that process can take time, and it won't wait around. JavaScript will not wait. It will move on to whatever the next command is underneath. So we want to call back so that we can execute some logic once that thing is complete, right? So in order to do that, we need to give it a callback. So this callback, we're going to actually just pass a function definition directly. And for those of you that are new to JavaScript, those are called anonymous functions. It's function. We're going to give it a parameter and the curly braces. So it's literally taking the word function, its parentheses with its parameter, and its block, and just passing it as like an actual object, like an argument, directly to the other function. So just so you guys can see over here, it's taking from here to here and passing it as an argument to the get method. Okay? What's basically going to happen is HTTPS is going to reach out, try to grab the URL. Once it has the URL data back, it's then going to take whatever response it gets, it's going to call that callback, and it's going to shove the response into where we currently put a placeholder called client. It just passes it right to it. So it calls the callback and gives it as an argument to client. Little confusing, but you'll get used to them. So with client, the object, client is cool because it actually has an event system in it. So we can actually listen to events on it. The event we're going to listen to is called data. And this is where we get into callback number 3. So client, this one takes a callback as well. It listens to the event data. When data fires off, it executes a callback. Trust me, there's much better libraries than this one, but it requires us to do an installation, and I'm avoiding that. All right, so we're going to do function. Give it a parameter. I think data works just fine. And the block, and put myself in the middle of it.
One function inside of another function, essentially.
It's a function inside of a function inside of a function. It's like those Russian dolls that go in, the nesting dolls. Yeah. It's exactly what it would be closely. And then to make matters worse, we're going to call this one up. Because we're done. We've got our data back. We can now use that callback function to now take our response and send it out to wherever it needs to go to be dealt with. So that's what we're going to do. We're going to call callback, and we're going to pass it data dot to string, just because that will actually give us a to string call on data, which will give us back our insult. The funny thing is we're actually going to rewrite this with promises, and the code gets worse. It's so much longer. But it looks better, and it reads better. All right. Let's call this thing, right? It's just a function right now. We haven't actually executed it. So let's call it. So we're going to call get insult. And what argument does insult take? Yeah, it takes a callback. So why don't we just pass it in an anonymous function? So function, I'm going to give it a parameter so it can shove the argument into it. Don't worry, I will walk through this and explain how it's working. I'll just leave that on the screen there for a second so you guys can get that out. All right, go ahead and put your cursor in between those curly braces and hit enter. And then we're just going to console log insult. Nope, not name. I'll explain why in a second. All right, I'm going to start at this end of the room and quickly explain this. Actually, I'll just use my mouse. I'm going to zoom out just slightly. Okay, so hopefully you can see that because I want to explain all this code in one block. If you can't see, please move up. All right. The first line of our code. I'm requiring an HTTPS library that's built into Node. That's all I'm doing. Just like you would if you did import or whatever you do in any language when you include a library. That's what line 1 is doing. Line 3, I create a function, right? Just like you would any function. Just a simple function. Takes a callback as an argument, right? So I give it a parameter called callback, and then I close out the whole thing on line 4 or on line 11, which I'm going to put a space between. There, a little bit more readable. Here's where the complexities start. Actually, the complexity doesn't even start. Line 4, just a variable with a string value, right? Very simple. We've done that before. Complexity starts on line 6. Line 6, HTTPS is an object, and it has methods and properties on it, right? And the method we're using is called get, okay? Get takes 2 arguments. It takes a URL, whatever your URL is that you want to pass it, and it takes a callback function. Instead of creating the function outside, right, we're just going to pass an anonymous function in because we're going to use it, abuse it, and be done with it. We don't need to use it again. Right? So we're just going to use an anonymous function. When https.get executes, it's going to reach out to that URL and it's going to look for a response. When it gets that response, it's going to take that response and it's going to call that function and pass it in as an argument. Because it's doing that, we need something to capture the argument. So that's why we're using client. Client's going to capture that response. Now that we have client available to us, we can actually use client and take a look at the method .on. .on is a method that's basically an event listener. It listens for the event data to occur. Don't hyper-focus on that. Just understand that that's what it's doing. It takes 2 parameters, right? Or 2 arguments, sorry, data, and the second argument is function. So we just give it another anonymous function, and basically what's going to happen is when the data event executes, it's going to call that function, and it's going to take its response and jam it into data. So now that we have data available to us, we can call our callback function that we originally started with, call to string on it, and it now becomes available to us in our function call. On line 13, this is where we actually call the function, right? And we pass in a callback function. Insult, just to see if you're following along, who can tell me what insult is going to be equal to? What's that? Exactly. It's going to be equal to data dot to string. That's what insult will be equal to. Because that's what we're passing through the callback. That's what's going to be available to us. So now we execute console log, and we fire. And it is 100% okay to be completely confused right now and have no idea what's happening. That is definitely okay, okay? Because we're going to do this so many times that you'll get used to it over time. You will get used to it. Trust me, you'll be like callback experts by the end of this course, okay? But for right now, it's totally fine if you have no idea what's happening and you just want to cry. That's totally okay. All right, we're going to save this. And then if you're an emotionally fragile person or you are easily insulted, I recommend not running this code if you use that URL.
I'm so insulted.
Are you completely triggered? Isn't that what the millennials say? I'm triggered. Are you tilted? Oh, I recalled the wrong thing. So node async. Here we go. You are as idiotic as a foul, corrupt, butt full of yucky, bad, puny skunk crap. Cool.
I'm actually getting.
That's mean. That's the meanest one I think I've ever gotten in the 3 years I've done this. That's the meanest one I've ever gotten. Wow. That's a conversation for the therapist, that's for sure. All right. Why don't we take a 15-minute? I think we've earned it. We'll resume. Cool. All right. So I want to talk a little bit about promises. Promises are not going to clean this code up, unfortunately, because that is the nature of HTTPS. This library, most people don't use this library anymore. They use something called Axios. That's like the go-to. Or there's requests. There's better libraries. But unfortunately, in order to teach you about those libraries, we have to learn NPM Package Manager. There's a lot of other steps. Okay? So to avoid that, we're just going to use the HTTPS, and we're going to use this code, but we're going to update this code a little bit. So what I would like you to do, let's create a new file so that way you have the original code, right? So let's create a new file, and just call it promises.js. And then what I would like you to do is copy the contents of async callback.js into promises.js so that we have a good starting base and we don't have to type all this stuff out all over again. There we go. So the good news is a good amount of it's not going to change, right? We're just going to wrap some of it, and we're going to wrap it in something called a promise. The idea of promises is they're supposed to help basically take callbacks and make it a little bit more readable and understandable. As a programmer, you should be able to kind of see what's happening. Basically what happens is we take our entire function, we wrap it in this thing called a promise, and it gives us two brand new methods. One is called then, and the other one is called catch. Then will execute when the promise fulfills, whether it fails or passes. Doesn't matter, it will execute. However, when you pair it up with catch, you get this really cool side effect, which is basically that then will execute on only successes, and catch will execute on only fails. So you can actually very easily read the code. Get insult, then console log my insult, catch if the insult fails. Okay? So that's basically what we're going to create. So let's do that now. So the first thing I'm going to do, this callback that we have as a parameter, we don't need that callback as a parameter anymore. So go ahead and delete it. So now it's just get insult with a set of parentheses. That's it. Because the promise is going to give us callback methods anyways, we're going to utilize those. So everything basically stays the same. This URL stays the same. It's this code in here that we're going to wind up encapsulating. Okay? So what I would like you to do is just above, I would actually like you to take from line 10 to line 6, so the whole HTTPS block, tab it in one. So it's just like moved in a little bit, right? So that way we can easily see what we're wrapping. Once you've done that, go ahead and put your cursor above it and just make sure it's slightly outside of it, right? This is where we're going to put the promise. Those of you that have had JavaScript in the past and have actually instantiated an object before are going to recognize, wow, that's not a problem. The only problem with this classroom is that it's on the same level as the kitchen, so like they're constantly moving up and down. Sorry, I didn't mean to F-bomb. Anyways, we're going to wrap this thing in the promise. Those of you that have worked with objects before in JavaScript and instantiated new objects in JavaScript will recognize this syntax. Those of you that haven't, this is how we instantiate a new object. So we're going to do a return. We always return our promise. New promise. Promise takes one argument, a callback. So we'll just use an anonymous function. And that looks like that. That's literally the whole syntax line. Okay. What I want to do is this curly brace and the parentheses and the semicolon at the end of that statement, I want to move them so they're at just after this HTTPS call. So I'm just going to highlight them like so. Okay. And then either Control X or Command X or cut whatever you want to do, or delete it even if you want to. Command X. And then, like I said, we're going to put it after the HTTPS one. The one thing I hate about callbacks is just the readability. It gets so much harder to read them the more nesting you go. That's why I really cannot stress enough that if you have difficulty with code formatting and you're not really keen on code formatting, I would download something like I'm using Prettier. Prettier will auto-pretty my code, which means it will tab it in and all that type of stuff. Use some sort of code formatting tool. Okay, it just makes it a lot easier for everybody involved. The promise, the function that it's going to call back, it's actually going to pass it 2 arguments. So we need to be able to capture those 2 arguments. The first argument it's going to pass is a resolve callback. What that basically means is as long as your code is successful, you will call resolve. The cool thing is you can call resolve wherever you want. There's no limitation to where you call resolve, right? So generally, you would call resolve after a successful thing has occurred, right? The second parameter is reject. And I'm sure it's pretty easy to understand what you're going to do with that, right? If you have an error, you're obviously going to call your reject at that point. So now the cool thing is this callback that we've written already down here, what are we going to replace the word callback with, do you think? Resolve. Exactly. We're going to replace it with resolve because we have our solution. We've successfully done what we want to do. We're now going to resolve our promise. Our promise is now resolved. When we call that callback, what actually happens is it's going to pass that to the then method that we will see later on. Next, I want to be able to call the reject, but we have to actually add a little bit of code in order to do that. If you put your cursor on the set of curly brace and parentheses that are in line with HTTPS, so make sure you're in that line, okay? Same with you guys. That's just too wide. So HTTPS to here, right? You're going to put your cursor right here, just before the semicolon, because we're going to move the semicolon to the next line and chain on a new command. So there you go. Semicolon's now floating in the middle of the yonder for no apparent reason. We're going to add dot on. We're going to listen for an error. And if we get the error, we're going to call the callback, pass the error to it, and reject it. I think I did that correctly, or did I do it in the wrong spot? I don't know why it's freaking out here. Oh, I see. Well, then fix it. Silly thing. It doesn't like how far it's indented. It's upset about it. There. It's you doing it. I save it, and it gets mad that there's 6 indents, but it's it doing it. All right, so we're going to call our function, do our client thing like we did before, only now instead of callback, we're using resolve, right? And then we have an on error, which basically will occur if HTTPS gets the wrong URL, it will throw an error. Now, when that happens, we can reject the error and pass it on to our actual function call. Anybody still typing that out just before I move on to actual function call? No? Cool. So if you come down now to the function, go ahead and get rid of all the stuff inside there. So all you have is the get insult call. Put your cursor on the other side so it's just between the closing parentheses and the semicolon, and hit enter so you're on the next line. And then you're going to do dot then. Dot then. Do it one more time. Dot catch. When we resolve our promise, it's going to pass to dot then. When we reject the promise, it will pass to the catch. Okay? So we want to be able to take the data to string and actually do something with it. So we'll pass in a callback function in here. We'll give it some sort of parameter so it can pass data to string in it. And then we'll just console.log insult. Then with the catch, it's going to give us the error. That's why it says reject error, right? So we'll just do function. We'll take an error. And we'll just console.log the error. Like I said, not less code, unfortunately. Promises are really super handy. We use promises quite a bit at work, especially with our new AWS Lambda systems that we're working with. We use promises quite a bit. Just because they are more readable, they're easier to see what happens. It's kind of like syntactic sugar for try-catch would be the closest thing I could think to compare it to. Now if you open up the terminal, I'm a little nervous just because of those red lines up there that it might not work. I don't think I missed anything. I'll find out. No, it worked. You are as pointless as an ill-decaying puddle of spiteful, angular fish buttholes. All right. So like I said, promises, not going to necessarily reduce your code, but they do make it a little bit more legible. Because what you can see is you fire off the get insult function, right? Now you can catch the successful response. And you can catch the successful error, or sorry, the fail error, right? It kind of separates your code and encapsulates a success and an error. Next week we're going to look at async and await. And async and await renders all of this a lot smaller, and it makes things a lot more readable and a lot easier to use. But there are times you can't use async. And that's whenever whatever it is you're trying to attempt doesn't return a promise, you can't use async. So we'll talk about that next week, though. Any questions about promises? It is totally fine if you don't, because we are going to work with them quite a bit. Okay, cool. So I have a short 10-minute quiz, but just based on time, I'm not going to do it in class. You have till midnight tomorrow with 2 tries. I'm going to recommend you do it on your own, not work with another person, because the whole idea is to try to give me feedback so that I can actually see how you're progressing and how much you actually understand, right? Then I can actually modify the course based on that. So please do it on your own. Okay. The next little piece we're going to learn is just some changes to our JavaScript code. This isn't really going to affect those of you that are new to JavaScript because you're just going to be like, cool, that's JavaScript syntax. Those of you that worked primarily in JavaScript last semester in the Intro to JavaScript class, some of these are going to seem new. Most of it won't. We're going to take a look at ES6 because we're going to be using ES6 so much. ES6 stands for ECMAScript 6. It's JavaScript. It's still just JavaScript. It's just you now have some cool little things that you can utilize in Node. You had them in the client as well, but we're going to use them quite a bit in Node. One of those that you've already used is let and const, right? Let and const are variable declarators. They basically define the scope of your variable. Let and const are always scoped to what syntax? Does anybody remember? They're block scoped, right? The difference between block scope versus functional scope is functional scope means it's only scoped within a function, which means it has to be defined as a function, right? Block scope basically means as long as it is between a set of curly braces, it is scoped within that scope. which means if you define it here, it is not accessible outside of it, right? So we've used let and const quite a bit. The differences between let and const is let is mutable, means you can change the value of it. You can declare it and not assign a value to it on declaration if you don't want to. You can assign it later. That is totally fine. Const is a constant, which means the value can never be changed, which means it's immutable. It also means that when you declare it, you must assign it a value at declaration. Okay? The good thing is Node will blow up and remind you if you forget. So, cool. Let's do some ES6 stuff. Let's create a new file. We'll just call it ES6. I think that makes the most amount of sense. JS. And the first thing I'm going to show you, because we already really know let and const. You know what? Why don't we create a let and const? So this is a const. I'm going to say const DOB, which stands for date of birth, equals, in my scenario, 1978, 12, 22, because that value is never going to change. I can't bend space and time. I can't change my birthday. Whereas my name, because we can be progressive, might change at some point. Sean McKinnon. So I'm going to store that in a let because it's mutable. It might change at some point. ES6 introduced constant let. It also introduced some very cool loops that we now have available to us. The for of loop and the for in loop, right? The for of loop basically iterates over an array. So if I have an array, so let's just do const temps equals 1, 2, 3, 4. And I want to iterate over that array. I do for. That structure you guys already know. Still has the curly brace structure. All that type of stuff is the same. Inside of it, I have my initializer first, right? So I have let. Why don't we just do temp? The next little piece of syntax is a bit different. Of temps. What that basically says is for each element in this array, right? So for each temperature of temps, execute whatever inside this block, right? So if I do console.log temps, or temp, sorry, the first time it iterates, it'll spit out 1, then 2, then 3, then 4. Okay? Incidentally, if we have an object, right? This is an object literal for those of you that don't know. Can't type today. Age 23. That is an object literal. I can actually iterate over the keys in the object literal. Yes.
Can you use backtick in that?
Yeah, you can definitely use backticks. Yeah. I meant to, and then I just completely went against myself.
Just I'm trying to get used to using it, so I wasn't sure if you had to lock it there.
Yep. Totally can use backticks. So to iterate over the keys, it's for let key of bio console.log key. Now that is one thing that annoys people about the in. It's not of, it's in. Let key in bio. My apologies. That is one annoying factor to a lot of people is that the key in bio, it's only the key that it's going to return back. It's not the actual value of that particular property, right? So it'll return back the property name, but not the value. So if you want to spit out the actual value, what you would have to do, I have console log there, so I'll do another console log underneath it, bio, and pass it key as an index reference. And then that will reference the property. There is a way around this, and I did put it as a little bonus inside your notes so that you can see it. Using object entities, you can actually spit out key and value. and destructuring. Cool. So those, some of you already know, for in, for of, you guys already know, some of you already know that. What you may not know is about the very cool ES6 function that you have available to you, the function syntax known as an arrow function. Arrow functions are really cool, and if you've used lambdas before, they might seem fairly familiar. But the arrow function, the most awesome power of an arrow function that I didn't explain last semester is the context of the keyword this, right? You know the keyword this? The keyword this is in reference to its owner object. So wherever you are in your stack, right, wherever you are within your function structure, when you call this, it will reference whatever owner object it is currently within. This, the arrow functions, they ignore that context altogether. They don't create new context, right? And the cool thing about that, it means that if you use an arrow function within a regular function, it actually maintains its context for the keyword this all the way through. And I can say this 9,000 times and you will look at me completely blank because it's hard to try to put into words what this actually does. So why don't we actually take a look at it syntactically. We're going to create a function called person with a capital P because we're going to create an object, essentially. We're going to instantiate it. Up to this point, before this point, in order to maintain the context of this throughout my application, I had to reassign it. So what I would do is I would create a variable called that, and I would assign it this. There are ways around this, though. You don't necessarily have to do this. You can do something called binding, but that's kind of confusing as well. I think this is probably the most common way I've seen. Then I can start using it like that.age is equal to 0. I'm going to use setInterval, and I'm going to pass it an anonymous function. And I'm going to set its timeout to 1,000. And I'm going to increment age. And then I'm going to console log age. Now, if you look, I'm using that, right? I've taken this and I've reassigned it to that, and I'm using that throughout my code. Okay? Leave yours the way it is. I'm going to change my code so it uses this inside of this set interval, and you'll see what the problem with it. So I'm going to change it to this.age, this.age, and make sure this.age is set over here, which is totally fine. This is going to blow up because age is going to have no reference. And I'll show you what I mean. We'll open up this thing, node ES6. I get 1, 2, 3, 4 from the stuff above. And I get, hold on, what is it doing? It just crashed. It completely just closed out. Oh, I need to call it. So sorry. Was not paying attention to that. Let peep equal new person. That's the missing piece. There we go. Okay, here it goes. Nan. Nan. Nan, nan, nan. What does nan mean? Not a number. And the reason why it's not a number is because this.age is not defined, has no value. Nothing has happened to it. It's not incrementing. It doesn't exist. Because once we've gotten into setInterval, once we are inside that function, we have lost the context of this. This now becomes this function here. That's its owner object. So it's lost its context. So to fix that, we create a variable called that, right? Go ahead and change these out to that. So you're that, right? And if I re-execute it, now it works just fine. And that's because it's referencing this property now, because we've given it its context. That's fine, but now we have arrow functions. And arrow functions make it so this isn't even an issue. We can actually pass an arrow function and maintain our context for this and its owner object all the way through our code. And the way that looks, just take all of this code here, copy it, comment it out, and paste it below. We're going to make a few slight changes. The first change we're going to do, we're going to get rid of the var that. We don't need it anymore. Goodbye. We're going to change that back to this. But for this to work, we need to replace that function with an arrow function. Double click the word function, hit delete. Make it go away. Put your cursor after the set of parentheses, hit space, type equals, greater than. It is now an arrow function. A guy I work with calls that a hash rocket. That's what he calls it. But you can see why it's called an arrow function. I have my parentheses where I'm going to put my parameters, and I'm pointing to the block I want to execute. Go ahead and save that. Now when you open up your terminal and execute, it will do the same thing as the last one was, but now we didn't need to reassign this to another variable. Cool. Because arrow functions are so super fun and super important, you will notice in your notes, is anybody still typing just before I switch over screens? Okay. You'll notice in your notes, there is a wonderful table right here that shows you the different syntaxes of arrow functions and how they can be written, because you will see it in all these different ways. So let's just do a couple of them. We'll jump back over. Let's say 2 params and a return. That looks like this. You have a set of parentheses. You have param1, param2, your arrow, and a return statement. The reason why this is freaking out is because it wants to be assigned to a variable, because right now it is the equivalence to an anonymous function. So I can assign it to a variable, so we'll just say const 2 param. There we go. If I have 1 param, I would just exclude one of the parameters. That's it. But I can actually go one step further. If I have 1 param, I don't need the parentheses at all. I can actually get away with excluding them entirely. So I can write const 1 param equals param1, like that, return param1. That is completely valid. Because I'm only returning, that's all I'm doing. I'm not executing any other logic. I have one singular line of logic. I can actually do this all on one entire line, and I don't need the curly braces, and the return will be implied. So if I want to rewrite that entire statement with that type of syntax, I can write it this way. And what that basically says is param1, pass it to the body, and return. That's literally what's happening in that statement. And now lazy AF will be equal to that function, not to the returned value. These do not execute automatically. These are anonymous functions, which means in order to actually get the value out of it, you would have to call lazy AF. we'll be writing tons and tons of ES6 arrow functions. All right, cool. We already know about template literals. Do I want to do destructuring? You know what, we'll do destructuring when we actually encounter it. Why don't I show you probably the one thing you're going to love the most? Just a ballpark, how many of you took Intro to JavaScript last semester? Okay. So last semester, do you guys remember that horrific thing about prototypes? And we took prototypes and we created new objects with prototypes. And then we did like inheritance with prototypes and stuff like that. It was super, super confusing. Yeah, you're probably, because it was so super confusing. You blocked it from your memory. That's what happened. It created trauma. That's what it did.
It's nice, like the way it works is really nice. I get the concept. But
But it gets so much nicer with ES6. It gets so much nicer because, for example, if I wanted to create a student last semester, I would have to create a function called student, like so, right? Like that. I would have to define its arguments in the actual body, right? So this dot ID is equal to ID. I would pass ID, name, and age up here. This whole thing would become a constructor function.
yeah.
Then if I wanted to add methods to it, for example, output, I would call student.prototype.output is equal to a function. And then I could console.log that and say, whoops, this.id, so I'll move that up a little bit. This.name is this.age. Right? And that for a lot of people wasn't too bad. A lot of people did manage to get around it okay, and they handled it okay. But when we got into inheritance, it got really tricky because you had to make sure you reassigned your prototype, the prototype over, or it wouldn't work. There was a lot of crazy things. Well, with fear of a revolt for this, there is a much easier way. A way that might seem very familiar because the syntax is almost identical to Java syntax of doing this same thing. And that's the ES6 classes. ES6 actually gives us a class which does all of that, but you don't see it because it's obscured from you. It's abstracted away, and it wraps this whole thing as a class, which makes a lot more conventional sense. So here's what it looks like. The same thing, but as a class, would look like this. Class, student, with a set of curly braces. I want a constructor function, so I create a constructor function. I want it to have ID, name, and age. And the assignments are still the same. This dot ID is equal to ID. This dot name is equal to name. There are libraries that can actually add setters and getters, auto setters and getters for you. And if I want to add the output function, I simply define it as a method inside the class. Okay, where do you want me to wait? On that prototype?
Yes.
Okay, just going to scroll the prototype down a little bit. There you go. And the cool thing is that both are instantiated the exact same way by just doing your variable equals new student. That's it. If you add a set of parentheses and give it some values, you'll call your constructor and immediately instantiate it with the constructed arguments.
Okay, so that output is for the class student.
It is. It's for the class student. Can I scroll down a bit?
Yeah.
Okay. Yeah. I mean, it's very familiar to in PHP. It's Ruby's probably a little different than Java's because you don't have data types, right? But in Java you do. But for the most part, that should seem fairly familiar. And like I said, instantiating it is not very hard. Let student equal new student, the ID, the name, and then the age. All right. And if you want to output, like call output on that, you would just call student dot output, like so. Nice and simple. And the cool thing is we won't be using the prototype methods. We'll be using this. We'll be doing classes in this class, so it'll be a lot easier to get used to it. We'll be doing it for our React side mostly. In the notes, I will be using export module a little bit. All right. And incidentally, if you want to extend it, right? If you want to actually create inheritance, super, super simple. Say I have a person. I would just do class person extends student. And that creates inheritance. And then I can go ahead and fill up my person class. So very easy. Way easier than prototypes. All right. Who needs a break? Out of curiosity. Nobody? Want to learn about NPM packages first? And then we'll figure out if we want a break. Okay. Or we might even be able to end slightly early, which would be nice too. All right. Cool. So this is all ES6 review. There is a lot more. Feel free to take a look at that lesson. There's also a cheat sheet posted there that you are welcome to have. Those of you who have had tests with me before know that I allow cheat sheets in class during tests. So make sure you just keep track of that stuff. ES6, much simpler to type. It doesn't mean you're going to be penalized if you don't use the ES6. If you're more comfortable typing in regular old school vanilla JavaScript, you're more than welcome to do that. There's no penalty as long as the code still works, right? That's the whole outcome. ES6 will make your life a lot easier though. Any questions about the ES6 stuff? No? Cool. All right, let's close that off. We've got a couple of steps that we have to do. So I'm going to actually, I'm going to leave that alone for a second. I'm going to go to my browser, and I'm going to navigate to GitHub, and then I'm going to ask a wonderful question. Does anybody in this class not have a GitHub account? Does anybody not have a GitHub account? Okay. Has anybody not pushed to Git before? Okay, cool. I'm going to take you at face value. All right. What I would like to do, we're going to create a new repository for the blog we're going to be creating. So everything we've done up to this point is basically like review stuff and a little bit of catch up on ES6. Going forward, our examples are always going to be building on our blog. So we'll be in the same folder all the time. What I'm going to do in order to manage our project, instead of having multiple folders of you just duplicating your code from week to week, we're going to use the power of Git, and we're going to use the power of GitHub's branching, right? Every week we'll create a new branch, and when we're done our branch, we will push our results up to master. So you're going to get that whole experience of how to create a branch and how to merge it into your master branch, okay? Which is a good experience for you. The end result will be a master branch with 12 little part branches, right? That you can always go back and take a look at and see what you actually committed that day for code, okay? So what I would like you to do, create a new repository. And you can call it whatever you want. I'm going to call mine Comp 2068 Thursday. So Comp 2068 Thursday. And the cool thing is you can literally use the same names because your owner will be different anyways. So. The description I'm going to use is a blogging platform. And I'm going to keep it public, and I recommend you keep it public too, right? Because you want to show it off. You don't want to have to invite people to see it. And you might be like, well, what about our credentials, Sean? What about our database credentials? What about our login details? I'm going to show you the power of environment variables, so that's not even an issue. Your credentials will never be published. So you won't have to worry about it, which you should get used to anyways. Because even with a private repo, you shouldn't be publishing your credentials. Okay? So that's the first thing. The next thing is initialize this repository with a README just to make our lives a lot easier during cloning. And then go ahead and click Create Repository. And we will get our wonderful repository. Yay! To clone this repository, you're just going to click over where it says clone or download, right? But before you do that, you see where it says branch master? You'll notice when you click down, it gives you a little search field. In the search field, you can actually type a new branch in there and create a brand new branch. Now, you can also do this in your terminal or your Git client, right? And then publish it to GitHub afterwards. Some people find it just easier to do it this way. So I'm going to show you the simple way to do it. And then at some point, I'll post a cheat sheet of Git commands that you can do in the terminal. All right, so here I'm going to just call this part 01. And then you'll notice, once you type that in, you now have a button that you can click, which will now create part 1 for you. When you create a branch, it will take whatever branch you are currently on and duplicate it into the new branch, right? So every week when we create a new branch, we'll go to master, create the branch, which will duplicate master, which should be up to date, and then we can work on that particular thing. So you'll always have the code from the week prior, right? Cool. Now we're going to go to clone or download, click the little clipboard thing, make sure that you're cloning with HTTPS and not SSH unless you understand that and you've already created keys and you're like all cool with SSH. Which you guys should try to force your Linux teacher to teaching you guys how to create keys and all that type of stuff. All right, once you're done that, jump over to your terminal. I'm just going to type in CD and put myself right in my home directory. You can navigate to wherever you want this blogging platform that you're going to work on week to week and make sure you put that file in there, that folder in there. And then I'm going to do git clone. Actually, before I do git clone, I'm going to do git -- version and hit enter. If you get an error, you do not have git installed. Just out of curiosity, how many people got an error? Oh, it's like the sweetest sight ever. You have no idea. Cool. Then we're going to do git clone space, paste it in. If you're using Linux, you have to hit Command Shift V, not Command V.
Sorry, how did you get the Git version again?
Git -- version. So git space -- version. You don't have to have the same version as me. That's totally fine. Yeah. Git does not change that drastically from version to version, so we're fine. As long as we can clone, we're good. Okay, go ahead and hit enter. It's going to tell you it's cloning. You're going to see a couple of remote checks, right? You're going to unpack it, and then it's going to be there. Now, the thing is your files are not currently in the directory you're in. It actually creates a brand new directory for you on your system that you will have to now CD into. To do that, you just type in CD and then the name of the branch. No, sorry, the name of the directory, which is comp. For me, it's comp 2068 Thursday. 2068 Thursday. There we go. Now, some people ask me, how do you get this? I get that because I'm using iTerm. Those who are working with Macs, depending on which shell you're using, you might get the same thing. Do you get that?
No.
You don't get the branch name? Oh, you're using the default one? If you're using the default one, you won't. If you want that same kind of information of what branch you're on, this little bit of structure here where it actually tells you your path, stuff like that. If you're in Windows, I recommend downloading Fish. Fish is a good PowerShell. It gives you that same kind of stuff. Or you wait till Microsoft Terminal comes out, which is supposed to be soon. And if you're on Mac, iTerm. All right. If you type in ls, the only file in there, or dir, sorry, if you're in Windows, the only file in there will be your readme. Right? You'll also notice that we're on the master branch, which means any code changes we make will be in master, not in part 1. We want to be in part 1. In order to be in part 1, we need to check it out. The first step before we do that is we need to retrieve our branches. So we're going to do git fetch. Git fetch is going to pull all the branches down for us, and we now have them accessible to us. To check out the branch, it's git checkout, and then the name of the branch. Now, I'm lucky, and I can type in part and hit tab, and it will autocomplete. A whole bunch of Windows people on Monday said they can't do that. It doesn't do that for them. So you need to know the exact name of your branch, which is probably just part-1, right? You hit enter, and you should see that it has switched over to the new branch. Okay. That's why I'm deliberately leaving the code up there. So which part did you get lost at, do you think?
My stuff got unpacked.
Okay, so after unpacking, you're going to cd into the repositories directory. What did you name your repository, Steve?
The same as yours.
Okay, so then you're going to cd into comp 2068 Thursday. So if you type in cd comp and hit tab, it should autocomplete. Are you in there? Cool. And then you're going to type in git fetch. So git space fetch. That will retrieve your branches from the GitHub and bring them down. After that, you're going to type in git checkout part-1. And then that will check out that branch. When you do that, it should say something like this. Part 1 set up to track remote branch. Did it say that? You're only typing up this part. Did it say it switched branches?
Yeah.
Cool. Then we're good. And that's where we ended. Okay, so now we want to open this project into our IDE, right? So you can either navigate the hard way to your IDE, right? Navigate to your IDE, go to File, Open, right? Navigate to wherever that folder is. So mine's in my local, like my home directory, comp 2068 Thursday, and I'm going to open the whole project in there. Right. If you're using Sublime, you might be able to type in subl dot in that directory, subl space dot, so SUBL space dot, and it will open the directory immediately for you. In Windows, if you're using VS Code, you can also type in code space dot, and it will open it into VS Code for you. Some people it worked for, some people it didn't. I don't know, it seemed to be hit or miss. I know on my Mac I can't get it to work, and I think it's because at some point I've overridden the word code. So, which sounds like me. Cool. We're ready for the first piece.
How can I show the exploit KB something?
Collapse the sidebar?
Yeah.
Control KB. Possibly. Yeah. Yeah.
Shell again.
Yeah, I certainly can. All right. There you go. No worries. For the rest of you, go ahead and create a new file called app.js. app.js. And then when you're done that, go ahead and open up your shell again.
Is there a reason why you show me branch?
Yeah, it's just because it's a limited terminal. If you want to be able to see it, I would download Fish.
What's the ESL Lint library?
What is ESL Lint? So ES Lint is an ES6 linting. So what linting essentially does is it assesses your code and then tells you if you're meeting best standards, if you've used something inappropriately or something like that.
That's supposed to load the ESL Lint library.
Yeah, I uninstalled mine because it was driving me up the wall. I don't know what Michael did with his.
This is just fishshell.com.
I think so. I've never actually installed it myself. I just know that's the most recommended one.
Where do you want us to create the new file?
In that directory, in your comp 2068 directory. Just at the root. All right. Are you good? Cool. All right. Or are you just giving me a thumbs up? Okay. I'm going to create a new file. I'm going to call, if I can, I'm going to create a new file, and I'm going to call it app.js. Okay? And it's going to be empty, which is totally fine, because we have another step. In our terminals, right? Terminals, shells, command prompts, the black void of horror, right? Whatever you want to call it. I'm going to clear mine so you can actually see what I'm doing. In order to use packages from NPM, and they are super important to us, we're going to have to do a few steps in our terminals. First, let me tell you what the NPMs are. So NPM stands for Node Package Manager. Have any of you used Grunt or Gulp or, yeah, you've used Gulp. Composer, Gems. Does anybody use Ruby Gems? No? I don't know whether Java has one. I'm sure it does. What about apt-get or wget or any of those guys? All of those things are package managers. The idea is that there's a repository that exists with a list of packages that have stable versions that people maintain. They are trusted, they are certified, and they are signed. And the reason why that's so important is because you should be able to retrieve these packages without accidentally downloading a virus, right? Or downloading malicious code or anything like that. That's the importance of a package manager. Package managers are guaranteeing you that the community has vetted the package, which means the package you are getting is completely safe to you, okay? Package manager that we're going to use for JavaScript is called NPM, and it stands for Node Package Manager. And the reason why we're going to use it is because it helps us get rid of redundant code, right? Code that's already been figured out. Somebody's already invented that wheel. There's no reason for us to invent it again, or it's super complex, right? Often packages will wrap things like binaries, so like C binaries and stuff that are super complex for us to use, and we can just download the wonderful package and make our lives much easier. The big package that we're going to install today is called Express. Express is a server that basically what its purpose is it listens for requests that are coming in and handles responses going out. It's known as a middleware, which basically, for those of you that might be familiar, back in the time when they used to deal with phone conversations between two people, there was an operator, right? And she would take the requested phone call coming in and patch it to whatever phone number they were trying to connect to. Incidentally, Bell, Rogers, all those, it still does basically the same thing, but now it does it digitally. There's a middleware that listens to the request coming in. There's a phone number in that request packet. It then connects to the endpoint using that phone number. The middleware is very important for us because it was basically going to handle when somebody types into our address bar /blogs, for example. We're going to be able to take a look at that path that they've asked for and then give them the appropriate response using something called a router. You guys have used routers before, you used the MVC. We're not going to get into depth into router in this class today, but next week we will be exploring routing quite in depth. All right? Today we're just going to write something very, very simple. In order to use the Node Package Manager, though, we have to basically take our application and say, okay, this is now a NPM app, right? It's an NPM application. And the way we do that, we type in npm init, and we hit enter. It's going to ask us a series of questions so that we can create our own little application, our own little Node application. The first one it's going to ask is what we want to call our package, because it's no real different than us actually creating our own Node package, right? I'm fine with the default name that's there, so I'm just going to hit enter. The next thing it's going to ask is what version number I'm currently working in. I'm cool with 1. I mean, we're like pre-alpha at this point, but we'll just accept 1. Description, go ahead and fill that out if you really want to. Basically, we're building a blogging platform, right? It's totally up to you what you want to write there. Entry point. The entry point is basically what file in our file structure is going to be our point of entry for the user. When they actually make a request, when anybody uses our application, what is the file that's going to be the main file? And it's going to be app.js, so just leave it and hit enter. Test command, I haven't decided yet if we're going to do testing in this class. The problem with TDD is it tends to take a lot of time to teach. It also takes a lot of time to implement, so we probably won't use test-driven development in this class. That being said, if you want to utilize a test platform, I recommend Jest. It's very simple to grasp. It's easy to use. It's probably one of the best ones. The other one, the rival one, I would say is Mocha. But we won't be using a test platform. So you can hit enter on that. The Git repository, it should just be the default Git repository that you have connected. Keywords, not necessary. Author, that's you. I'm going to type in Sean McKinnon for mine. License, I'm just going to leave the default as ISC. It's going to show you a preview of what it's going to create. I'm cool with that, so I'm just going to hit enter, and it's done. You should notice, though, that it's now created a new file inside our directory. We have this file called package.json. The package.json file is actually a list of things that our app requires in order to execute and run properly. It's going to be a list of all our node modules that we need, so our dependencies. It's also going to be a list of any scripts that we want to run using the npm. Jump over to the package.json file and just give it a quick open. And let's just take a look at what it's doing. So you can see all the different things that you typed out, right? Comp 2068, our blogging platform. It pulled that from Git. That's where it actually got that description from. We have one test script in there. You'll notice the repository information. There's an author, license, and it's even tried to attempt to give me a home page, but it's connected to my README. Yes, Mo?
At any point of time, can we change like the, let's say the description or the name?
Yep, you can actually edit this file. That's totally fine. Yeah, you can completely edit this file. It's recommended that when you install node modules or update node modules that you use your command prompt and not edit them inline in the package.json file though, right? But any of the other information, any of the metadata, that's what that stuff's called, description, authors, keywords, stuff like that, that's metadata, you can edit that to your heart's content. So we're gonna actually add one more script in here. The cool thing about this script is it's literally bash commands. You guys are taking Linux, right? Are you guys learning a little bit of bash? No? That's really unfortunate. You should definitely be learning bash. We can actually type a bash command in here. And then to execute these, we just type in npm and whatever the name of the script is, right? So the script's name there is test. We can actually create another one, which we're going to do. We're going to do comma, and we're going to call it start. And then in these quotes, we type in the bash command that we want to execute. How do I execute a node file? I type in node and the name of the file. That's literally what we're going to type there. So I'm going to do node. And what's the file that I'm likely going to execute? App.js. That's exactly it. Now, as I was explaining, dependencies are not something we're going to add in manually. npm gives us the ability to install dependencies and uninstall dependencies quite simply using their command line tool. The only dependency we're going to use today is called Express, and it's very simple. We're just going to open up our command prompt, and we're going to type in npm install express --save. Now you can actually leave out --save depending on which version of Node you're using. I'm going to keep it in there just for, it doesn't break it. Let's put it that way. You can also do npm I instead of install. And actually, incidentally, if you spell install incorrectly, Node actually has an alias for it and picks it up and still installs it, which is kind of cool. Hit enter. It's going to go through and it's going to actually retrieve from the repository Express, but it doesn't stop there. It's actually also going to grab all of Express's dependencies. So it's going to go track down every dependency that Express relies on and download those for you, the most stable, up-to-date versions, and it's going to put them in your app directory. Now, you can see there that it downloaded 48 packages from 36 contributors. So you've wound up with 48 brand new packages as part of your application. If you open up your IDE and open up your sidebar, you will see now that you have two new pieces to your application. You have a folder called node modules, and you have a file called package.lock.json. The package lock basically locks your version of your packages in place, so you don't have to worry about them updating and your whole application breaking, right? It will only update your package to the newer version if you explicitly tell it to. Otherwise, it locks it at that version, okay? The node modules folder, go ahead and click it open. See all these wonderful folders in here? These are all libraries that have been downloaded that are now available to you as a part of your application. These are the dependencies that Express is relying on. And every time we install a new dependency, it's going to download more packages, and it's going to dump them in there unless they already exist. If they already exist and the version is a close enough match, it will use the one that is a close enough match. If it doesn't match, then it will download a new version for it and patch it up. Okay? The cool thing is you don't really need to worry your heads about that. It does it all on its own. You just need to let it do it. Cool. We're almost at the end here, so the only thing we need to do now is actually create our app. So go ahead and make sure app.js is open. It's only 5 lines of code that we're actually going to type in total to get a working server, which is super, super fun. Just let me scroll, find the thing. All right, line 1. Line 1, stop. Line 1, silly thing, stop. All right. Line 1 is the library we want to use, which is Express. You might remember this when we actually required the HTTPS library, only now we're requiring the Express library. So this is requiring our node module, and we are assigning it to Express. Over the coming weeks, I will explain how this actually works. This exports information to here, and we will actually see that in depth over the next couple of weeks. For now, just suffice to say that we've just taken Express and jammed that whole object in an Express variable. Next, we want to create the app, so it's const app equals Express, and we call it like a function. So we're going to execute Express, and whatever its return value, we're going to store in the const app variable. I lied, it's not 5 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lines. That's 4 out. 5 structures. All right. Next, we're doing app, not sap, app.get. This takes 2 arguments. It takes a path, just like HTTPS.get. It takes a path, and it has a callback function. The path is done using regular expression. Basically, what we say is when the user navigates to this path, this thing that I've defined, I want you to execute this logic. That's basically what we're saying. Routing, right? Routing in a nutshell. The first path I want is the home path, which is pretty easy because it's just the /. That represents the root. So when they go to localhost 3000, they're hitting that particular marker. Then I'm going to do comma.
Has to be single quotes.
Nope. Can be double quotes, can be backticks, can be literally any type of quote character, as long as it's a quote character. The next part is going to be the logic I want to perform, which is a callback function. And I mean, what is the point of learning arrow functions if we're not going to use them, right? So let's use them now, and I'll show you how it kind of like reduces a bit of what we're writing. So we're going to do an arrow function. The get method is going to pass 2 arguments. It's going to pass our request object, and it's going to pass a response object. The request object is going to contain all that wonderful request information that you guys learned when we talked about APIs last semester. Those of you that have not taken that, the request object contains the header information that the user sends when they make a URL request on the intranet, and it also contains a body. And the body can contain things like query strings and that type of information. But that all goes inside that request object. The response object is ours. It's what we're going to use to actually send information back to the user. It's how we communicate back down the pipeline and give them what they're looking for. So in this scenario, our user is accessing our home directory. Now we're going to give them a response. And we're just going to type in raw text. We're not going to deliver a file. We'll do that next week. And that's it. The path to listen to, what path they're actually taking a look at, and what we want to actually execute once they've done it. Let's write one more. Let's do an about page. App.get. I'm going to call it /about just because it makes sense. Again, request, response. Thank God for block scoping. I can use the same variable names over and over again. And I'm going to respond, send. I like long walks on the beach. Now I'm not quite done yet. I've got all these things. What I've done here is I've created these little pieces and I've registered them to my app. That's basically what has occurred here. I've registered 2 brand new routes to my app. So when Express executes this and we get a request on the home, we will send this response. When we get a request in the about, we will send this response. The problem is, though, is I need to get Express to actually listen. It needs to hear these requests, right? Right now it's not. But it's not that complicated. It's simply app.listen. The port, right? Some of you took networking, right? The port number we want to actually listen to, so the hole we want to punch into our router so that we can actually listen on it. It's going to be 4,000 or 3,000. You can literally give it any port number you want. I think there's a limit to the number of numbers you're allowed. And then a callbacks. So I'm just going to do a nice little arrow function that just basically console logs listening on 4,000. And that's it. That's the whole application. That is your entire server currently. We're going to build on it, obviously, next week a little more so that we can add in the ability to handle HTML and stuff and all that wonderful stuff. But we'll take a look at that next week. All right, let's execute this. So jump over to iTerm. I'm just going to move it over here. And in order to execute this, does anybody remember the script that we created? That's right, start. So we call it npm, and then the name of the script we want to execute, which is start, and we hit enter. And if you did it correctly, it should say listening on 4,000. Okay. So now there's 2 different ways we can actually go check to see if this works. We can curl, and just out of curiosity, how many of you have actually curled before? You haven't left, bro, right? The other way we can do it, the very, very easy way to do it, is go to your browser, go to localhost :4000. So in my browser, I'm going to open it up. I'm going to navigate to localhost 4000, hit enter, and I get, hey there, world, right? Make sure you do localhost :4000. It always tends to trip people up. And then the last, I want to see my about page, so I simply add a / after 4,000 and type in about, hit enter, and there's my I like long walks on the beach. Maybe a little bit of tea. Yep, I'm going to handle it in 1 second. So for those of you that have that working and everything's A-okay, you are welcome to just go ahead and leave. Next week, we will actually push this up to GitHub, and we will merge it into our master branch, so you'll learn that next week, and then we will deploy to Heroku at the beginning of class. All that information in that first half hour of next week's class will be what you need for your lab. I will post the lab requirements and information. I didn't realize that it was empty. Thank you. And next week we'll be doing routing. So you'll learn about routing in depth. We'll be doing controllers, and it'll be the first touch of a template engine. So we'll probably use Pug in order to learn what we're going to do for a template engine. Anyways, that's basically it. Hope you guys have a great weekend.
So if I can proceed to stop.